We're going to close out inverse functions by looking at their graphs. So we're going to take a new look at the process of finding the formula for an inverse function. Same process as in the last video, we're just going to look at it from a different perspective. We're going to use this new interpretation to find points on the graph of the inverse function, and then we're going to extend this technique to graphing inverse functions. And of course, we'll use that on an example. So let's remember what the process is that we go through to find the formula for the inverse of a function f. First, we set up the equation y equals f of x. Then we solve for x in terms of y. Then we change all the y's into x's, and that will give us f inverse of x. Now, another way of saying the same thing is we start with the formula y equals f of x. We solve for x, which gives us x equals f inverse of y. And I need to point out, y equals f of x equals f inverse of y, exact same numbers make those two equations true. It's just a different form of the equation. And then we switch our x and y to get y equals f inverse of x. Now, if we look at this in terms of the graph, right, our graph is usually for f, y equals f of x. What this is telling us is if I want to graph y equals f inverse of x, I'm going to go through that same process. It's going to be the same graph as y equals f of x. The only difference is we're switching the roles of x and y, right? So we take y equals f of x, we solve for x, which is just the same equation in a different form, then we switch our x's and y's to get y equals f inverse of x. All right, so here's a graph of y equals f of x. I'm not giving the formula because we're just going to use the graph to figure that one out. And here is a point on the graph. It's kind of hard to see. It's x equals 4, y equals 6. So that tells us f of 4 equals 6. But remember, what we just figured out is that if we switch the roles of x and y to find our inverse. So for f, our input is 4 and our output is 6. We switch our inputs and outputs for f inverse to get f inverse of 6, and the output is 4, which means the point x equals 6, y equals 4 is on the graph y equals f inverse of x. All we did was we took the x and y coordinates of our point for f, and we switched them to find a point for f inverse. All right, so now let's go ahead and see if we can extend this to find a graph of y equals f inverse of x. Well, so all it's going to be is the same graph as y equals f of x, except we're going to switch x and y. So here's our graph y equals f of x, and if we switch x and y, here's what we get. And it's kind of hard to see on the graph, but the vertical axis I'm now labeling as x, and the horizontal axis I'm now labeling as y. Otherwise, it's the exact same graph. Now, we could be smart Alex about this and just say, well, that's the graph of y equals f inverse of x. It's the same graph, except we switch the roles of x and y. But ordinarily, we want to have the graphs with the y-axis being vertical and the x being horizontal. So what we're going to do now is translate this graph here into what it would look like if y is the vertical axis and x is horizontal. So here's what y equals f inverse of x looks like. So again, now I have the y on the vertical and then x on the horizontal. But it's going to be the exact same graph. So I kind of have to do some perspective stretching to see if I can figure this out. So let's look at the graph on the left. As y gets bigger, and remember, y is the horizontal axis. As y gets bigger, starting at y equals 0, x also gets bigger. So you can see starting at y equals 0, which is right here, x is getting bigger as well as you follow the hand up the graph. And not only that, but the graph kind of curves toward the x-axis, towards the x-axis, right? Sort of cupping towards the x-axis and cupping away from the y-axis down here. So we're going to do the same thing here. We're going to start at y equals 0. Now y is the vertical axis right here. We're going to start at y equals 0, right? X equals 2. And then we're going to sort of curve towards the x-axis, where the x's get big as the y's get big. Now, as y gets smaller, starting at y equals 0, so again, here's y equals 0, as we go in the other direction, notice that now the graph sort of cups toward the y-axis. And also x is getting smaller. So two things. First of all, x is getting smaller, right, as we go backwards from y equals 0. And also the graph curves towards the x-axis, both the x-axis and the y-axis. So it's curving, cupping in between the x and y axes. So we're going to do the same thing over here, cupping in between the x and y axes like this. And there we go. And the rest of the graph just continues in the same way. We cup towards the x and y axis. It just sort of curves in the same way going down here. So this is going to curve in the same way going out here. And then there's the graph of our inverse function. Exact same graph as on the left. All we did was make the y-axis vertical and the x-axis horizontal. So go ahead and try these out on the Graphing Inverse Functions PDF, and that is right next to the video that you're watching.